afternoon, everyone. My name is Ramzul. It's a pleasure to welcome you to this session on scaling innovation from breakthroughs to global impact. Today, we'll explore what it takes to move cutting-edge technologies to large-scale market adoption. We have a panel of speakers here who are shaping the innovation landscape from different angles. To my left is Mr. Ricardo Angel, CEO and Managing Partner for Piva Capital. Then we have Mr. Kevin Dunn, Chief Commercial Officer, VEIR. And last but not least, Mr. Eric Brown, CEO for Planted Solar. Each of our panelists brings a unique perspective from investing in startups to deploying next generation energy solutions. With just 20 minutes, let's dive straight into the discussion. Ricardo, since I know you from before, let's start with you. Okay, Piva Capital invests in companies at the inflection point between scientific breakthroughs and mass market impact. What are the key strengths that you look for in a startup to determine if they are ready to scale?
Okay, so what we do is we always invest in inflection technology companies like VEIR, like Planted Solar, right? And so what do we look for? We look for a number of things. Obviously, we invest in what we consider breakthrough technology companies, companies that are going to be doing things in a dramatically different way. And so what we look for is differentiation on the technology side. We look for strong management teams. We look for companies that are going to go after a massive market and they're going to be able to take that technology to market in a very economic way, right? So we're looking for economic solutions. So, great.
Yeah. Kevin, your technology offers a 5 to 10 times power capacity increase while reducing line losses by 90%. How does your superconducting power delivery solution integrate with existing energy infrastructure to enhance efficiency and reliability?
VEIR's superconducting technology is positioned in two different markets, both the data center market as well as the utilities market. And so integrating into either one of those market segments require that we integrate seamlessly with the existing set of technologies. And so it's a key component that we integrate seamlessly to be able to get the 5 to 10x value that our clients and the technology can achieve. And so to do that, we have some key pieces of our technology that we developed from a hardware standpoint that allows us to make the transition from conventional conductors into the superconducting material. That's a key piece of how we make it seamlessly integrated across any industry and get the superconducting properties that we need. On the other angle as well, not just hardware, but is design. We talked a little bit about the impact of significantly different technologies. No one in the world knows how to design right now with superconductors. And so we're building both a hardware solution to be integrated, but as well as a design and reference design to be able to get out broadly into the industry and help integrate our technology into the next stages of both AI data centers as well as utility scale solutions.
Great, yeah. This is a question for Eric. Solar has grown exponentially, yet deployment remains complex. How does Planted Solar change the game in making new sites viable?
Great. I think in spite of the exponential growth, we're still at the beginning of the beginning in many ways when it comes to solar, storage, wind, et cetera. We've built globally 2 terawatts of solar PV capacity, mostly in the last 10 years. There's something like 70 to 75 terawatts that need to happen by 2050 to decarbonize based on your own estimates. So if you extrapolate that out, there's going to be increasing pressure on site selection and challenges associated with actually getting sites built in the right way they need to be. So solar has the challenge, wind has the challenge of needing space, whether it's on a roof, on the ground, whatever the case may be. So you have to find space for it. And we're already seeing pressure in the industry where effectively the best sites are kind of already gone. So we deliberately address this in a way that increases the flexibility for adapting your site development process to incorporate different kinds of terrain, accept greater geotechnical risk for ground mount solar as well, and probably most importantly, take up a lot less space. So for a conventional system, you can build with 2 or more X increase in overall energy efficiency or density on site just by simply doing a smarter origination and structure of the actual racking itself. And that's complemented by automated installation. So you increase the total optionality for sites that can be integrated into the grid at the right spots where there are space for interconnection. Obviously, we hope that you increase the amount of sites that are viable based on more grid capacity, and also have more flexibility for putting power where it needs to be closer to load as well, where you have more behind the meter and off-grid applications.
Back to you, Ricardo. Scaling industrial deep tech startup is a unique challenge, so I know you have a tough job. What's the hardest part of getting them to scale? Is it capital, is it execution, or market adoption?
It really depends on the specific technology, right? And so, for example, Kevin here, he's at VEIR, right? Very cool superconducting technology that has many different applications. Right? Long term, they're going to go after large, long transmission lines. Shorter term, they have a very cool product for power distribution within data centers, right? And so that's a market that right now is just booming, right? And the power demand there is incredible. If you think about how much power you need to distribute within data centers, it's massive, right? If you think about currently, a typical server rack requires 12 to 15 kilowatts per rack. A typical data center right now is between 30 to 50 megawatts, which is pretty good size. Next generation, like in the next couple of years, the next generation of these data centers are going to have racks that require between 120 to 150 kilowatts per rack. Each data center is not going to be 30 to 50 megawatts anymore. It's going to be between 700 megawatts to 1 gigawatt, right? The amount of power is massive. And so on something like that, I'm very comfortable with the traction that we have to be able to do pilots and demonstrations. My largest concern on something like that is, what is it going to take for hyperscalers to actually adopt a technology like this in a data center at a commercial scale, right? And so they have really good traction. They're working on a couple of different pilots and demos. If you think about the reliability that data centers need, right, at commercial scale, we're talking about 3, 4, 5 nines, right? Getting to 5 nines is going to take a while. And so my big question is, how much data do they need to see before they actually scale this commercial, right? And so in that case, they have the budget, right? In that case, they have the will. And so it's just about being able to get convinced and getting the reliability required. And so, so that's on one example, right? Depending on the technology, right? Many times what we see is also in what we do, right? And we focus mainly on things that are related to deep tech. Many times what we need to also do is build that large first commercial plant, right? If you think about things related to e-fuels, if you think about things related to other areas, sometimes financing of that first large plant is a big challenge. So that's just 2 examples. I can go on, of course.
But given the scale, do you think the demand will keep up?
Absolutely. So absolutely, right? And so as you scale technologies, right, there many times, well, sometimes it's reliability, some other times it's cost, right? And so if you're able to prove the technology that is working as expected, right? If you're able to show that the technology at scale is going to be economic, depending on what you're going after, then absolutely the demand will keep up, right? And so the demand, for example, for VEIR is going to be, for the next couple of decades, we think the demand is going to be huge, massive, right? If we think about, planted solar is our most recent investment, right? And so I've been investing for 23 years. I've made a lot of investments in renewables, and renewables is a very tough space, right? It's a commodity, and so over the years I have invested in companies that are looking to displace silicon, right? And some of those companies fail because silicon got to be so cheap, right? I have invested in other companies that have developed microelectronics to be able to optimize how much power you get from those panels. So those silicon panels, right? We did super well there. And so when we actually got to plant it, they have something that is very, very simple, but simple is not easy, right? And Eric can tell you more about it. And I'm super excited about planted solar because what they do, they're doing it in a very simple way, and they're able to take advantage of the current economics of the solar panel, right? Solar panels used to be 10, 20 bucks, 20 years ago. They dropped to a buck, $1 10 years ago. And right now they're in the US at 20, 25 cents per watt, right? If you go to places in India, it's a fraction of that. And so they went at, how do we make solar installations cheaper, better, quicker today? And so that's the problem that they're solving, right? And so I can give you all this speech, all this spiel, which I love, right? But the one-liner why I love this so much and why this is going to be able to scale up so rapidly, right? So right now, I think they don't have a huge challenge. It's more about execution. So you have the challenge that you have to execute. You have to have the right team, and I think we have the right team. But the one-liner, the value proposition for planted solar is that today you can lower the levelized cost of energy for solar by 20 to 30%, right? So let's say 20%. That's massive. Yeah. And so that's why I'm so excited about it, right? So sometimes maybe the issue is with funding. Sometimes the issue is with proving that the technology is reliable. Sometimes, many times, right, the problem is execution. So you have to make sure that you have the right team there, right?
Okay, back to you, Kevin. We have seen innovative grid technologies stall because they require significant infrastructure change. What lessons can we learn from the past failures?
Yeah, there's many lessons to be learned from the past failures of some companies who tried to introduce these new technologies. I think part of what we've learned is there's a potential to have death by pilots, right? Iterations upon iterations, deployments upon deployments of pilot projects that really aren't convincing customers that there is a fit and there's a need and there's a solution that can be solved for. And so we are very intentional about what each pilot is going to achieve, both for us, for our clients, to be able to de-risk the technology and advance it through and achieve product market fit, both in the data center and the utility side. And when we start to think about what are the real things to be learned from the technologies and the innovations that have come to market and been successful, is that it really helps when there is a market driver and a market demand. Hence why data centers is such an important piece for our business today, because the demand is massive. It is massive with a sovereign buyer who has the choices behind the meter to make adoptions of new technologies and design changes that drives the highest priority that there is right now in the market, which is the best performing AI data centers. And so we see ourselves in a position to capitalize on that and to be a catalyst to support that innovation. But the key piece is they're convincing them and de-risking the technology and showing it along the way. And so with that market opportunity comes a great advantage for the first mover adopters. You look at the market today from gas turbines, combined cycle turbines that are 3-4 years out from a lead time standpoint, transformers 3-4 years out. Our delivery lead time today is measured in weeks. So not only do our first mover and our first adopters will get faster speed to market, they'll be offsetting the longer lead time that will drive their projects to revenue faster with the highest performance that is going to be introduced by our technology in the data center space. And so that's why when we see some of the challenge that others have done, we've carefully tried to craft our path through those lessons learned and de-risk the technology, but also position it for speed and scale that we think the market's going to demand.
Right. This is for Eric. Automation and AI are transforming solar deployment. But how do you ensure rapid adoption in an industry that still relies heavily on conventional construction methods?
Yeah, great question. I think getting back to what Ricardo mentioned already, one of the first core principles that Planted really applies to everything is simplification first. So right. We've started to really think about the entire end-to-end process for how you do design, development, and final construction for a conventional solar power plant and tried to strip out as much of the effectively unnecessary steps as possible first. With that, you can reduce the amount of materials, the amount of fasteners, everything that actually goes into it. Once we've done that, we've got a relatively simple structural balance of system, and fewer actually installation processes that actually need to happen. We've also eliminated in process a lot of the typical civil costs that happen, earthwork, et cetera. And then once you've simplified, you can kind of digitize and automate. So everything thereafter is run by an end-to-end software platform that helps to accelerate the design processes, all of the engineering, as well as the construction management and operations. And then finally, once you've done all that, we're adding robotics into the field to automate what remains. So there's material handling and logistics completed with precise installation by machines in the field. And I think with that, we've carved out a part of the process that's the most sort of resource, logistics, and sort of labor intensive. And then really the challenges that are left over are what we're already quite good at, which is letting people do the right integration into a load or into the grid. And so we're kind of separating out what you can simplify and automate from what otherwise needs to be part of the conventional construction process, and really double down to make sure that's better. I would say fundamentally that also allows for reductions in overall costs from the total plant. So you have room to have higher interconnection costs or other things where you need to integrate to drive down the total costs or increase the value of the energy that you're actually producing, so that you're making sure that the commodity is doing the weight for you.
So this next question is for everyone. Innovation is only as impactful as its ability to scale, right? So what is the number one bottleneck preventing your technology from being deployed at a full commercial scale? So Ricardo, you can rest first. Let's start with Kevin.
The number one bottleneck for us, I would think it would be the timing of balancing our pilot projects that are de-risking our technology, but also building a pipeline of those next set of commercial projects. And so that's a very delicate balance. What we don't want there to be is a lag between the revenues that we see on our pilot projects versus our full commercial scale. And so if we think about the objective of those pilot projects, it's really to de-risk the technology in front of our clients so that they have the confidence that the performance that they've seen in the pilot is ready for full commercial scale, which means you effectively have to build a plane while you're flying it. And so this gives us a very complex task to balance, is both the pilot project's performance, but as well as the confidence with a next set of commercial projects that can be booked quickly behind it. We want to prove the technology and execute it quickly. This is a challenge when we start to think about we're in the infrastructure business, right? Infrastructure projects takes months and years to execute. So to wait for the full pilot to be online, to show that it's de-risked, and then start the process of getting these commercial projects is a challenge. And so what we really want to focus on is find those early adopters, find the companies that have the confidence in our technology to begin working with us to design the next set of data centers, the next set of utility lines, so that we can position these commercial projects at full scale once the technology has been proven and de-risked and then ready to go with the next set of deployments. So that's what we would see.
Eric?
I think it's very similar. For us, we're relying on standard conventional modules that are produced globally. Those are known reliability, so we don't have sort of performance risk when it comes to actually energy generation. There is still that element where you're producing a commodity, it's supposed to last for 40 years in its useful life. And so banks need to feel comfortable with it and just getting enough proof points as rapidly as possible. So you have full access to conventional bank debt, project financing, tax equity becomes a big driver for all this. So I think it's just incremental pace of deployment so that you can rapidly convert into bigger projects, bigger scale, more regions, and increase applicability broadly. But we're ready to go. I mean, the core technology for us was really built from the get-go because it's all co-designed in a vertically integrated approach that combines software, in-field hardware, and robotics. And that sort of product technology de-risking process is past, and now it's more just about scaling up and ramping.
Ricardo?
Yeah, no, so those are great, those are very critical bottlenecks for those companies, right? As they were talking, I was thinking, so what are the critical bottlenecks, right? And so in some of our other businesses that are more capital intensive, finding that capital for that first large commercial scale plants, right, to be able to achieve some economies of scale, that to this day is still a big issue, right? And so a lot of people have identified, of course, that issue, right? And so there are different, depending where in the geographies that you're in, right, there are different incentives, there are different grants, there's different matching, loan matching programs, and different things that have been developed to be able to overcome those bottlenecks, right? I'll give you an example. We have I made an investment years ago in a company called Boston Metal, right? And they're doing great. And so they have been able to raise a lot of capital, and as they look to test the technology, to prove the technology, and as they actually go and build the last commercial plant in the next few years, they're going to still need to raise hundreds of millions of dollars, which is a lot of money, right? And so I believe that that's going to be achievable just because the value proposition is strong. It is so strong, right? And so on Boston Metal, the high-level pitch, right, is that they're developing a new process to electrify the way you produce steel today, right? And so the value proposition is that the cost to produce steel is going to be the same or lower than it is today, number one. Number two, is going to be modular. And so what that means is that since it's going to be modular, you're going to be able to make smaller reservoirs more economic, finally economic, right? Because since it's more modular, your plant is going to require hundreds of millions of dollars to be built, but it's not going to be billions anymore, right? And because it's more modular, then more and more reserves that you know where you're at are going to finally be economic, because, well, you're going to be able to make more money in smaller plants. And so very strong value proposition. Raising capital is still a big issue for a number of our companies. And so, we just have to work together to get over that.
Right. Okay, so we have come to the final question. So let's conclude on a forward-looking question. 5 years from now, where do you see your technology making the biggest impact? I have to start with Eric.
Yeah, for us, it's pretty simple. We exist to unlock clean, reliable, abundant energy as quickly as possible. And so we want to be deploying in all parts of the world that need that kind of power, which is pretty much everywhere. And then you can unlock all the other layers of decarbonization that come from that. We're pairing it with storage, enabling broad scale electrification. I'd say next generation decarbonization tools like green hydrogen, electrolysis, et cetera. So renewables are really key part of that. And most importantly, they need to be cheap and available where you need them.
Eric. Sorry, Kevin.
So in the next 5 years, it makes me think about some of the more advanced servers that are coming out through those OEMs like NVIDIA. In the next 5 years, by 2029 and beyond, you'll see server racks that are a megawatt. And so Ricardo had mentioned that they're at 15 kilowatts today. A megawatt is nearly unthinkable. And you start to think about the power density associated with a server at a megawatt level means that a superconductor's value proposition is absolutely outstanding. And so the market is moving towards us where we know that we can offset tremendously expensive and large indoor power distribution systems, and that when the market moves towards higher and higher AI-based server performance that requires a megawatt, our value proposition, our technology will all have been proven, vetted, and existed as a standard that more dense these servers get, a superconductor will power them.
Ricardo.
That's a great question, right? And so if you think about like electricity and power demand, growth coming up is going to be massive, right? So kind of like rough numbers according to McKinsey, right now globally, power generation is about 25,000 terawatt hours, right now. That's expected to be between 50 to 71,000 terawatt hours by 2050, right? So in the next 25 years, we're going to more than double the amount of power being demanded, right? And so how are we going to meet that demand? I think it's going to be a challenge, right? And I think the solution is going to be based on technology and innovation like this, right? So in 5 years from now, right? I'm thinking that we're going to do very well with companies like Planted Solar, right? Being able to hopefully build many gigawatts in the US and globally, tens, hundreds of gigawatts. I like it, Eric. and transmission, well, obviously data centers are going to be growing massively, right? My expectation, if all goes well, is that we're going to have a very cool, very unique solution within data centers. And then we're going to have some very interesting products for us to be able to tie the grid to deliver the amount of power that we need to the data center. And then I'm thinking maybe 5 years, it may take a little longer, but a solution like this is needed for transmission, hundreds of miles, thousands of miles worldwide, right? And this is going to be just part of the solution that we need to be able to meet the requirements, the demands that are developing every day. So super exciting. Great question. Thank you.
Okay, so thank you, Ricardo, Kevin, and Eric for your valuable insights. I think today's discussion has underscored the fact that while breakthrough innovations are essential, the true challenge and opportunity lies in the scaling of the solution for global impact. I think to our audience, I hope this session has provided useful perspective on overcoming the barriers to innovation deployment and growth. And before we close, I would like to invite all of you here to Energy Asia 2025, happening from 16 to 18 June in Kuala Lumpur, Malaysia. This event will bring together global industry leaders to discuss the future of energy transition, explore innovative solutions, and forge collaborations that will drive sustainable progress. It's a platform not to be missed. Once again, thank you to our panelists and to all of you for joining us. Enjoy the rest of CERAWeek. Thank you.
Thank you.